So, in Newton's law of gravitation, we looked at gravitation as a force of attraction between any two objects in space, right? If one of the objects is Earth, then instead of using the word gravitation, we use the word gravity. Right? So whenever we have one object as Earth and the other object is any object on the Earth or outside the Earth, we call it gravity. So gravity is a force, right, between the Earth and any object, right, which attracts the body towards its centering. So gravity is a special case, or is an example or a type of gravitation force. Now, if I say this is the Earth, and let us say there is an object of mass m falling towards the Earth. Right? This gravity, the force of gravity is applying a force onto this, and it is falling towards the Earth. What we observe is that the speed of this object keeps on increasing as it moves towards the Earth, and there is an acceleration. We can observe an acceleration in the body, its velocity is increasing, and this acceleration with which this object of mass m moves towards the Earth is known as acceleration of gravity, which we identify or indicate by the symbol g. Right? The objective in this video is that we will try to find a relationship between acceleration due to gravity g and the universal gravitational constant g. Right? So if you look at this particular object, it has mass m, its weight is given by mg, and we know weight is the force with which the Earth applies a force onto this. Weight is equal to mg, right? Now, by universal law of we have this equation: F is equal to g m1 m2 upon r square, right? So if we consider this particular object of mass m, and let us say we take the mass of Earth as me, right, then the force of attraction, or the gravitational force which the Earth is applying onto this, would be given by F is equal to g, where m is the mass of the Earth and m is the mass of the object, and r is the distance between the center of the Earth and the object, which can be taken as re square. Right? Now this particular equation, we call it equation 2, this is equation 1. Both of them represent the same force, right? mg and this force are equal. So I can write down mg is equal to g m upon re square. M would get cancelled, and then I would get the equation g is equal to g me upon re square, where m is the mass of the Earth and r is the radius of the Earth, right? And thus I obtain a relationship between acceleration due to gravity and the gravitational constant g and g, and it is connected to constants mass of the Earth and re square. Now the important thing to see in this equation is that there is no m in this equation, there is no mass of the object, right? That means this g is independent of the mass of the object. That means if this is the surface of the Earth and there is an object falling onto the surface of the Earth, its acceleration due to gravity would be constant irrespective of its mass. So if I have a smaller object of some small mass m, and I have a bigger object of mass m over here, right, what will happen is that both these objects will have the same acceleration and they will reach the Earth simultaneously. Right? This would be assuming that there is no buoyancy effect and there is no viscous drag due to air onto these particular objects. Right? If we consider buoyancy effect and viscous drag, then what would happen is we will see that the heavier object would reach the Earth earlier as compared to the smaller object. But if we ignore these two forces, then both of them would come to the Earth simultaneously. Right? So this is how acceleration due to g is related to the gravitational constant g. And in the next video, right, when we look at g and g more closely, and we will see how this particular value of g changes, right? How it varies with respect to altitude. If we go from the surface of the Earth, how does it change? If we go deep into the Earth, how its value is changed. And we'll see the variation of g in more depth in the next video. Thank you.